Welcome back to my channel, everyone. 3 tips here. What I have here is a little over 2 troy ounces of pure gold that's been quartered with silver, and then we pulled all the silver and the rest of the base metals out with nitric acid boils. So that's all complete. So now what we're going to do is we're going to refine this gold. First step is to make some copperas here. This is our copperas. I've got it dissolved in some distilled water. Copperas is iron sulfate. I'm going to add some hydrochloric acid to this to turn it green. This is some leftover copperas, aka iron sulfate, aka ferrous sulfate, from a previous video. Get this out of the way. We'll be using this for this precipitation. Now we're going to take this off of the heat. I had it warming. It dissolves better in warm water. One nice thing about copperas is that it does not produce any fumes. So I'm just going to take this out of the fume hood now. We're going to filter it and get it ready for our next precipitation. Here's a look at the gold that we quartered with silver and then removed all of the silver and all of the base metals with about 5 nitric acid boils. What we're going to do now is add this to a 2-liter beaker. I'm just going to add it right in. I've got some hydrochloric acid in a squirt bottle, and we'll use that to rinse the gold out. This is about 72 grams of pure gold here. So what I'm going to do for this first refining is add about, we're going to fill it up to about the 300 milliliter level with hydrochloric acid. Now what we'll do is add a little bit of sulfuric acid, and this will precipitate out any lead that may be present in our gold. About 1/2 milliliter should do it. Before I go any further, I'm going to start the time-lapse camera here. And now what we'll do is I've got some nitric acid, and I'm going to add about, let's see, 72 grams. Let's go with about just under 40 milliliters of nitric acid. I'll pour that right on in. And now what we'll do is cover this up, give it a stir. We're going to dissolve the gold on the heat now. Alright, we're going to turn the vacuum pump on, dampen our filtered paper, and there's really no need to, but what I'll do is I'll refilter this ferrous sulfate that we used in a previous video. Now we'll start filtering our ferrous sulfate that we just dissolved. We've almost got our copperas filtered. Nice clear green copperas solution here. In the meantime, let's go over here and take a look at our gold that we're trying to dissolve. Let's see if we've got everything in solution. I think we do. I think we've got everything dissolved here. Might be a few little bitty crumbs left in there. Tell when this reaction is complete. When we stop seeing fumes, red fumes forming in our beaker. So now what we're going to do is let this cool off. I've allowed it to cool just a little bit here. Now what we'll do is add some ice cubes. This will do three things for us. It'll dilute the solution, it'll cool it off, and it will precipitate out any silver chloride that may be present in our chloroauric acid solution. Now we're going to filter our gold solution here. It's cooled down to about the temperature of a cold glass of iced tea. I think there's a little bit of trash down in the bottom of our beaker. Not much. I don't think it's gold. Yeah, there's just some trash up in there. We've got the solution pulled through our filter. Here's what our filter looks like. I'm not sure what all that stuff is. We'll put that in the paper storage and hang on to it. Now we're going to add our gold solution here to a clean beaker. Let's get us a stannous test on our solution, just to verify that we have gold in solution. I know we do, but it's good practice to do this before each precipitation. Now we're going to precipitate our pure gold with the ferrous sulfate that we filtered out. I'm just going to pour the ferrous sulfate right in. It's not as dramatic as the SMB precipitations, but you'll see that the gold will come out of solution fairly quickly here as we add the ferrous sulfate. It takes a lot more ferrous sulfate to precipitate a given amount of gold. Boom. All right, let's see what happens there. Stir it up. We've got some nice flecks of gold that are floating on the surface of our solution here. You really can't tell because the color is so dark in here if the gold is settling out for us or not. It's a little bit frightening because I don't see a nice pile of gold building up on the bottom of the beaker like I'm used to when we do precipitations with the SMB. Here's another stannous test. Let's see what we got here. And as you can see, no reaction, which tells me that all of the gold is now precipitated out of our solution. So now what we'll do is just let this settle. Oh yeah, you can see some gold on the rod there. Let this settle, and then we'll get in here and get our gold out of this beaker. Here you can see there's a layer of gold forming down on the bottom of the beaker. that's what we want to see. Sometimes we can get this fine layer of gold to settle out by hitting it with some a finely atomized spray of distilled water. I think it's settled out fairly quickly. It's only been sitting there for about half an hour. Now what we'll do is I'll save this ferrous sulfate for a later refining, and what we'll do now is pour off our waste solution out of here into our temporary waste container. Okay, here's a look at the gold down in the bottom of our beaker. I don't have much experience using ferrous sulfate. I like the convenience and speed and ease of use using sodium metabisulfite. It's just so simple to drop a couple of spoons of SMB into the chloric acid solution and precipitate it out quickly. Ferrous sulfate does a better job at precipitating the gold because it drops just the gold, nothing else. But I like the ease of use of SMB. Here you can see I use too much probably, but if I just rinse it over and over with acid and water, I can get all of the excess ferrous sulfate rinsed off of our gold. That's one of the drawbacks of using ferrous sulfate. It produces lots of waste. I'm just going to keep rinsing with hydrochloric acid and water until we get all the color rinsed off of our gold. I've rinsed multiple times with hydrochloric acid and with distilled water. And if you notice, the solution here now looks colorless. But that was distilled water. You'll notice that if I rinse with hydrochloric acid, I'm going to see a little color form in here still. Hydrochloric acid does a better job of rinsing the color out of the gold than straight water does. Got some hydrochloric acid in my plastic bottle here that I'm using to rinse it. But if you notice, see the color in there now? After we add the hydrochloric acid does a better job of rinsing dissolved metals off the gold than just plain water. I've probably used a half a gallon of hydrochloric acid rinsing this gold now, and we're still pulling just a little bit of color. Not much, but a little bit. So what I'm going to do, I think, is this is ferrous sulfate. I don't have a lot of experience with ferrous sulfate. It's looking better. I mean, the solution's clearing up. I'm going to give it a quick rinse with some water. And now what we'll do, I'm going to add some hydrochloric acid to the gold, and we're going to give it a boil. This is hydrochloric acid. We're going to give it a boil, and this should clean our gold up for us pretty good. Here we go. It's been on boiling now for about 15 minutes. I'm going to move this big jug out of the way. What we'll do is we'll pour it off into this here, because I know the glass will take the heat in this temporary container here. So let's go ahead and pour off. Still got a little color going on in there. That's from the ferrous sulfate. It's one of the drawbacks here of using ferrous sulfate. Used about a half a gallon of acid to rinse our gold off. With some water. Should be high purity gold, just like it is in this beaker right now. Just got to get all that iron rinsed off. One of the odd things about ferrous sulfate is that it looks just like gold in solution. If you put some stannous on here, you'll see there's no gold there. Ferrous sulfate looks just like gold in solution, but the stannous test tells us there's no gold. I'm going to add about up to the 300 milliliter level hydrochloric acid. Now we'll add some sulfuric acid. Just a little bit, just in case we got any lead that made it this far. That gold in there really looks spectacular. Got a beautiful color to it. So now what we'll do, let me get set up here. Got our little beaker. Let me measure out about 35 milliliters of nitric acid. I'm going to dump that right on in. We're going to cover this up and redissolve this gold a second time. Here we go. Boom, look at it taking off. Took about 20 minutes. We've got everything to go into solution. Now we're going to pull this down and let it cool off. Our filter is nice and clean. We've got the solution pulled through. Someone suggested that we try an SO2 gas precipitation. So that's what we're going to do here. I'm going to get set up for that. This is sodium metabisulfite. I'm adding to the gas generator flask. Now let me pull the gold solution down off of here, get it out of the way. I'm adding some water to the gas generator flask to form a slurry in here of sodium metabisulfite and water. I've got an addition funnel here that's vented. I'm clipping the top onto this. Now we're going to install it here in the flask. This is full of sulfuric acid. I'm going to put a clip on here, make a gas tight seal. Our addition funnel is full of sulfuric acid. And what we're going to do is drop some of that sulfuric acid down onto the SMB that's here in our flask. And then the output of that will go into this flask that has sulfuric acid in it. I'm using a large 4-liter beaker to do the precipitation because this reaction happens best when we use a dilute solution. We're ready to try the reaction here. I'm going to add our gold solution to this beaker. This reaction happens best when we have a dilute solution. So I'm going to fill it up to about the 3-liter mark with distilled water to thoroughly dilute the chloroauric acid solution. Let's insert our delivery tube now into the chloroauric acid solution. I'm going to reach back here and we're going to turn this valve and start dripping some of our sulfuric acid down into our gas generator that has the SMB in it. And what this will do is start forming SO2 gas. Here it goes. I can see some particles of gold starting to form on the surface. This is about 1 minute and 30 seconds in. This always happens. I never get enough acid or gas flow to get a decent reaction. There we go. Had to increase the acid flow a little bit. Now we've got a decent flow of gas going in there. All right, I think I'm starting to see a little bit of a color change there. Yep, it's starting to turn light, a light color. Oh yeah, there it goes. If I got the concentration of that chloroauric acid solution right, we should see it turn nearly colorless before it flashes over and turns brown from the gold precipitating out. There it goes, almost colorless right there. That's amazing. That is amazing. Alright, here we go. We're going to flash over to a brown now. Bang. Real time. That's real time. That's not speeded up. Awesome. Absolutely breathtaking. Yeah, the gold, the precipitation has ceased. The reaction has ceased in my gas generator flask. So now we'll get this delivery tube out of the way. Here's our gold. Down in the bottom of our beaker. There's some flakes of gold up on top here. This is awesome. SO2 gas precipitation, said by many refiners to precipitate the purest gold of all. Let's make sure we got our gold precipitated completely. And there you see it. Negative Stannis test means all the gold has been precipitated. The gold looks pretty good in there. Let's see if I can knock some of these floaters down with some water here. Not really. Them things like to stay aloft. Let's see if we can get some of the gold off the inside of our beaker. It's just a jet of water out of a spray gun. Take a look at that high purity gold sponge down in the bottom of our beaker. I've allowed this to settle for a few hours, and now what we're going to do is we're going to pour off this waste solution into a temporary waste container that I have set up here. Alrighty, here we go. We're going to pour this off. The beauty of using the gas is that no chemical gets added to our chloroauric acid system or solution. It's strictly gas, clean, pure gas, SO2 gas, and that makes for a much cleaner precipitation of our gold. All right, here's a look down inside the beaker. Look at that high purity gold down in there. It looks delicious. Now what we'll do is transfer the gold into a smaller container to make it easier to handle. There's a small amount of gold left in our beaker here, and what I'll do is just put some aqua regia, heat it up, and dissolve that out and add it to our stock pot. Now what we're going to do is get the liquid off of this gold into our temporary waste container. At this point I would normally do a bunch of hydrochloric acid rinses and water rinses, but there's really no need to do that, because this gold right here, just like we have in this beaker, should be very high purity and not have a whole bunch of chemicals on it, because we didn't use any chemicals to precipitate it out. So that gold right there is ready to be melted as is. Got a melt dish here. I'm going to transfer the gold now. Beautiful. Down into this melt dish. Let me get some of that water out of there first. Let's take our gold over here to the melt table. Look at that stuff, man. Amazing. I'm going to set it down here and commence to melting up a gold bar. Here's our pure gold bar. It looks scrumptious. Nice, bright, shiny finish. And we got an SO2 gas precipitation in the new fume hood. Let's see what the weight is on this thing. We were expecting 74 or 72.4 grams of pure gold. Let's see what we got here. We've got 73.1. So we're a little over on the yield, which is fine. We'll take it. That's 2.35 troy ounces of high purity gold. And I hope you enjoyed the show. We installed that new light in the fume hood and brightened the place up out there. And someone suggested let's do an SO2 gas precipitation. And I said, that sounds like a good idea. I can't remember who it was. I wish I remembered, but a shout out to that person who said that. This will conclude the video. Thank you for watching.